Okay, assignment 3, page 4. We have solving a system, y equals sine of x, y equals cosine of x. So with these two systems, or with these two equations, let's say, when does sine x equal cosine x? Well, that happens when, let's divide both sides by cosine of x. That's what happens when tan of x equals 1. When does tangent of x equals 1? Well, that happens when x equals, let's see, that's going to be pi over 4 plus 2 pi k for k and z. And it's also going to happen at 5 pi over 4 plus 2 pi k for k and z. All right? Okay, so if those are the values, notice that gives us tangent of x equals 1, and these ones make sine of x and cosine of x both equaling radical 2 over 2, and these ones make sine of x and cosine of x both be negative rad 2 over 2. So to write up my final solutions, I would write them up as the pi over 4 plus 2 pi k, comma, that was in the quadrant 1, so that's going to provide a rad 2 over 2, and then we would have a 5 pi over 4 plus 2 pi k, comma, and that one's going to be in the third quadrant, giving me a negative rad 2 over 2, and this is for k in the integers. Okay, nice little review from the trigonometry there. Okay, unfortunately, I threw out all of my templates for these problems, so I'll have to do them on Scratch, so you'll have to give me a moment. We'll do that one last because it's got the most pieces to it, so let's reserve that one. Graph these inequalities. Let's do that one. Okay, graph, so that means I'll make myself a nice Cartesian coordinate plane. I'll make a t-table out of these to give me 0, 6 and 6, 0. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And less than or equal to, so I'll make solid line. And remember that I'm going to shade below. And then we have y less than or equal to 4. So there's 4. It's right here. So y being 4 would be this line. Have to shade below. And x being less than or equal to 5 would go through here and shade below. And so the final answer, since they're all belows, is going to be right here. You could also test a point like 0, 0 and verify that that's going to be the shaded region. Expanding a logarithm, let's see, this logarithm, exponents come out in front, and the products become addition, and the division becomes subtraction. So this would be 2 log x plus 3 log y minus half log z. And then, last one is the fun one. So let's bring it down and do it. Okay, you are decorating boxes for selling at a fair. It takes you 2 hours to decorate a small box and 3 hours to do a large. So we have small boxes and large boxes. Let me go x equals small boxes and y equals large boxes. And what is that information going to give me? It says that it takes, where's our constraint? Let's see, it takes 2 hours to decorate these, 3 hours to do these. There's our profit. Oh, there it is. We only have 30 hours available to work. Remember, it takes me 2 hours to decorate a small box, and it takes me 3 hours to do a large, and I'm restricted by the 30 hours. And it also says I will sell at least 12 boxes, so I need to make sure that I create at least 12 boxes. These are in addition to the trivial constraints. And then we're going to be looking at maximizing profit. So my profit equation is going to be the profit here, which is 10 on a small and 20 on a large. So we're going to keep this information as we move on to the rest of the problem. That is the first box or the first quadrant of our template that we had. Okay, let's remove this paper and put this one here now. And we'll bring this information into a chart to graph? We'll graph our constraints. So I'm going to draw a coordinate plane, and I'm going to graph my constraints. Let's use this one to figure out a reasonable, let's use the intercept method to make reasonable axes. So that's 0, 12, 12, 0. If I plug in x equals 0 here, y will be 10, and y equals 0 would give me x equals 15. So I got to get out to about 15 on all sides, on the x and the y. So let's go by fives. 5, 10, 15, 5, 10, 15. And then for this one, 2x plus 3y less than or equal to 30, we'll go 0, 10, and then 15, 0, and connect. Remember, we are going to be below this line. And then x plus y, 12, 12, so that's going to be 12, 12, there we go. And we are going to be above that line. And then the other two constraints are trivial. So we need to be below this line, but above this line. So where's that going to be? It looks like that's going to be in this region, isn't it? There we go. There we go. There we go. Okay, so this has three corners. Let's call them A, B, and C. The A corner is at 12, 0. The B corner is at 15, 0. And the C corner is the only one that actually takes any amount of work, right? That's where we have to find the intersection of these two. So let's do that. Top one is 2x plus 3y equals 30. The bottom one, if we multiply by 2, is going to, let's multiply by negative 2, would be negative 2x minus 2y equals negative 24. So when we combine, we get y equals 6. And remember, x plus y was 12, so that means x would be 6. So the coordinates of C are 6, 6. So if we now take that chart and its corners and come back to our profit equation, we can now replace this information into the profit equation and see where we're getting the most amount of money. So P of A would be to do 10 times 12 plus 20 times 0. That's 120 bucks. The profit analyzed at B would be 10 times 15 plus 20 times 0, and that provides 150 bucks. And then the profit at C would be, let's see, $10 at 6 and $20 at 6, and that's 60 plus 120, which is 180. So there's our happy place. So to make $180 profit max, we should decorate 6 of each type of box. And that concludes page 4.